to buy the information. As you can see, there's no value to the information at all, so the entire 35 cost is lost, and so the optimal decision is to not test. That changes, of course, as we have seen before, by going to larger risk tolerance values. So, for example, again, putting 100 in there, when we look at our results down here, we see a different story. Okay, we see that the value of information has gone up above 35, and so we have a positive certain equivalent net gain of sample information, and therefore the optimal decision is to test the market. On a strong test, go with a large plant, but on moderate or weak result, go with no plant. And again, the CEV star is computed by a formula. Since the gain is positive, we want to take the CEV given SI minus the cost of the test to get our CEV star. If it had been 0 or negative, then we would just go with a prior decision, and that has a value up there in N7 in that case. But again, these values will all change as the risk tolerance changes, and so we're going to have to do a risk tolerance analysis using a data table. Now, before we go to look at that table, though, I wanted to point out something interesting here that I just discovered in preparation for this recording. You'll notice that when I put this formula in here initially, I did the expression inside the logarithm term by term. That is to say, without a sum product function. I was multiplying the first probability times the first negative exponential term, and then I put a plus sign.